physics project, we were asked to discuss how we think that harnessing the heat energy that is lost in certain processes through power plants or manufacturers, the heat that's lost, how we can grab that essentially and reuse it to where we can maximize our heat expenditure and minimize our cost effectiveness over these experiments and processes. And I ended up doing my research on thermoelectrics. It is the process of taking a temperature difference and using it to produce energy. Thermoelectrics is a new idea used in manufacturing, and it is justified by the law of thermodynamics. The law of thermodynamics states that 100% of the energy cannot be used in processes such as running a car or working a power plant, because some of that heat energy has to be lost. And so thermoelectrics is kind of reversing that and taking the law of thermodynamics and almost trying to prove it wrong, so we can use 100% of that energy. While there is no process that has been able to use 100% of the energy, there are processes and experiments that are being conducted to see if we can regain some of that energy. Thermoelectrics almost works like a pipe and water. If you fill the pipe up with water and you flip it upside down, the water will flow down to the other side. And when you do this with the thermoelectric material, the electrons that are within that thermoelectric material will flow from one end to the other when you apply heat. One of the experiments that has been conducted for this is on wastewater ponds, and they take microbial cells and they harness them for energy. They put them in a process and withdraw their components and put them through a process in order to use this energy to power really anything. And it was done in a scientific study that we have in the United States alone, we have 15 to 20 gigawatts of energy located in these wastewater ponds, which could power up to 15 to 20 nuclear plants. The only reason that this wouldn't work in the United States is because we are such a powerhouse country, but it has been advised that developing countries could use it for a energy source. It is susceptible to ammonia leaks just because of the microbial products that are used, which can lead to contamination of the water. And they haven't come up with a process to allow that to not happen. Also, there's no way for us to transport or manufacture this wastewater to the other countries that could use it for sustainable energy. So there are a few kinks within each of these experiments and processes that I have found, but if there was a way to put all of these together, that would be a magnificent thing to come up with. Jonathan Polfer, I'm so sorry if I messed that name up, Polfker, from Northwestern University, adapted a thermodynamic block that he would connect to a battery, and as it was connected to the battery, they would flow heat through it, and the other side would cool simultaneously. And as it was being heated, voltage was applied to the battery, so it would gain more energy than what was being put into it because of the heating process. The issues that he faced were how rare the thermoelectric material is and how hard it is to be produced. The naturally occurring products are very rare, and there's not many of them, so that set them out to have to do research for products they could use by making them through physics. It's very tedious and it's very costly, and it's not done very efficiently, but they do have a supercomputer that can do it efficiently, but it still does take amounts of time, and they also have to go through, the scientists do, to check this by hand. So it had its kinks with the cost effectiveness and the availability of the materials. So this next one that we will discuss was very similar to Pulfker's processes, but they essentially eliminated the thermoelectrical material being needed. They went straight to the source of using the heat energy that has been wasted and pushing it into a battery. Scientists Lee and Chu from Stanford, along with Yang and Chen from the MIT College, they worked on waste heat for manufacturing facilities and power plants in the production of energy. They used the thermogalvanic effect to work this experiment, and that states that a battery is completely dependent on temperature. So they went along the steps that Pulfker had. They had 4 steps. One was heating the battery and then pumping it with voltage to allow more heat to be put into it, and then they would let it cool and restart the process all over again. So this process, while it is very cost efficient and it didn't take the research that Pulfker had to put into it, there were smaller issues with this one. While this process was a great advancement for science, technology has not caught up to the experiments that they have conducted. There aren't many technologies out there that could use this kind of energy source as of now, but as scientists move forward in the future, they could process their products to be able to use this kind of energy. That way we are conserving the other uses of our energy, such as coal and hydro and the natural or the nuclear plants. So they were way ahead of their time in creating this process. Like I said, each had its good and bad steps, but each step was still a process that would get us closer to a solution in the future. And as I was doing this experiment, I was thinking to myself, it would be kind of neat if we could take pieces of each of these projects and use them together. I was considering the fact that while there are the microbial bacteria that are in the waste products in the United States, if they could figure out a way to use that to harness the thermoelectrical material used in Jonathan's experiment at Northwestern University, then they could eliminate the processes of that research and the tedious work that they're having to do to supply the battery that they've been making. And that would be one of the ways to get around the processes that have restricted moving forward with that one. Also, I was thinking, while Jonathan had to use the thermodynamic material, there are certain battery companies, along with the Stanford and MIT programs, that have those components that can be used with the processes that they use. And if we could take that to a larger scale with cars and manufacturing plants to produce results, that would even be a way to go around it. While it is a growing field and there are many things that can be done to advance this, each day spent moving forward is a step closer to coming up with a solution. I thought that this topic was very interesting, and I honestly didn't really know a whole lot about it until I did start doing my research, and I thought that the waste products was actually pretty neat. Just seeing that you can take things that and you think are inherently bad and there's no use for them and making use for them. I thought that would be really cool.